Well, I've been waiting on this radio for 2 or 3 weeks because of the mail. It's been looping around. I don't have high hopes for survival on this one. I think this is a TRC 458, I believe. And the box that they put this in, should be the size of this radio. So that means there's probably 0 packing in here. It's covered up the label, but I mean, I can just feel it on all corners, so I'm kind of disappointed before I already open it, but I'm crossing my fingers that it's not totally destroyed. So let me get this open. Well, this is what we're looking at so far. I mean, this radio is big empty gap here, so I know it's been banged around. I mean, it is wrapped in bubble wrap, but this box physically is just an inch taller than the radio actually is, so something's going to be bent, I do believe. But like I said, I'm still being hopeful. I really wanted this one to be one that I could just go through and show exactly what I do and try to play with the camera more, but you know, get some close-ups and kind of take you through basic equipment style alignment. But okay, well, let me shut up. And there it is. I haven't looked at the rest yet, but this box was literally not even tall enough for this with its tall feet on there. So, got some straightening out to do on that. And this radio has a relay in it, so without any packing, I hope the socket or the board isn't cracked. And it probably is going to be, so. Okay, well, I don't see too much damage on the face of this yet, but I can see that the panel has popped loose in transit. And it's got a bend in it here on the corner. And they left this hook on here, which has, you know, been beaten on the side of it the whole time, so this might be a different kind of restoration video, or a video about how badly the post office sucks. This is also another case where on eBay I paid a little extra and it said FedEx ground, and they sent it to the post office on April 1st, I think it was. So this is a cruel April Fool's joke. Yeah, okay. I supplied my own mic, didn't come with one. Should have been all up. Now this is an unknown unit, because I guess the guy found it in his parents' attic or closet or something. I mean, not his fault whether it don't work or not, but the way he shipped it was awful. But let's see, squelch minimum, RF gain maximum. Ooh, she crunchy. I'm gonna break my own rule. Okay, what do we do? Audio, a little bit. Go ahead and try sideband, see if that C179 is toast. Audio, well, we got a little bit of power. We got a little bit of noise. There we go. I'm gonna have to clean these pots before I do anything. It's just gonna be a struggle if I don't. So, all right, let me stop there and start as my usual restoration procedure. All right, just got the top cover off. I haven't done anything to it yet. Let me find a pointer. I'll use a alignment tool. See the C179 that I'm always talking about. This tantalum, that's got to go. I shouldn't even really transmit it on it, because if that would have blew, I could have took other stuff. But this looks all stock and original so far. These Radio Shack versions of these 858 chassis have a really crappy power supply versus the Uniden and Cobra counterparts. So as part of this restoration, if I got enough room, I may switch this to a switching supply, but depends on what I run into on the other side. But this looks original-ish, so continue on to the bottom and get these pots clean, and then hook it back up again. And well, I'll change the C179 before I even try to transmit again, but we'll be back. I did take an opportunity to take the foot off and hammer this out, so just
before I even got anywhere else. I don't know why, but yeah, got that hammered out and put the feet back on.
Okay, all I've done so far is clean all the pots and change C179. Got a little yellow tin on in there now. It's a 50 volt. Audio. Hello, audio. She ain't putting out much on AM. Sideband. Audio, 1, 2, 3. Hello. About 8 watts. So what this is going to need, before I go willy-nilly recapping everything, I'm going to go through my list of 10 volt caps. And you can look at Radio Shack TRC 449 manual for this. It's the same radio, it's just a base version. Look at the list and find all the 10 volt caps and then try to find them on the board and replace them. I pretty much know where they're all at. Like these two bigger looking ones here, those are 10 volts. I'm going to go through and replace all the 10 volt caps, and then I'm going to kind of go through a quick little test to see if I can get more power. If I can, I'm just going to take it to like an alignment stage and see what I can get out of it. If it's not way too far out of spec, and I'll bring you along on how to do such a thing. But right now I'm also running off a DC. This didn't have a power cord with it, so it takes a 2-pin style like the Robyn and Teaberry. It just plugs in a little narrow 2-pin one with a click. But let me go ahead and change some 10 volt caps and do a little transmitter alignment on it and see what happens. Alright, real quick, like this list of capacitors I have on here, don't worry about these notes up here. This list of capacitors, C14, 42, whatever. This is the list of all the 10 and 16 volt. All the 10 volt ones are underlined. So C14, 49, 50, 59, 101, 102, 103, and 104. I guess 76 also. Just go ahead and replace those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So at least 9 or 10 capacitors you need to replace. Now the rest of them on this list are 16 volts. I usually replace those too if I take 1 or 2 out and check them and they don't look that great. Most of your 35, 50 volt caps are usually pretty good other than the one in the power supply. So take a screenshot or something here. C14, 49, 50, 59, 76, and 101 through 104 are all 10 volts. Just change them. At least minimum of 16 volt, but I do all 25 and 50 volt caps. It doesn't hurt to go up in value on that. So let me get to it. Okay, I'm about to remove this cap here on the left, and you see all this glue that's holding it down, how it's turned brown? The Tech Bond or Sony Bond, whatever they call that glue back in the 70s. When I get these caps out of there, that's one of the things you got to get rid of all of that. That's going to actually create a short here. Because this glue, when it becomes brown like this, it becomes corrosive and conductive. It can even eat the leads right off of stuff. Some later radios, you'll see it on the PLL, and you'll find that your radio don't work, and you'll go to check, and your PLL's pins are eaten off. So get rid of any of that kind of crap when you get in there. The best kind of tool really is just a dental pick or a little screwdriver. You can soften it up with a little bit of 91 or higher isopropyl alcohol. Soak in a little contact cleaner, something like that. Just soak it for a little bit. Once it's good and wet, just scrape it off with a dental pick or some kind of small screwdriver. Just be careful that you don't break any components. But this is also the time to see if any leads are corroded off, and that would be the time to replace whatever part is in that spot. So let me get these caps out and get this glue cleaned up, and I'll be back. Well, this escalated quickly, but I took all this apart to do a better clean, and man, that looks like crap, the channel window. But this thing here was just nasty. I had to soak it with Goo Gone, Windex, a little bit of alcohol. I don't want to take the white, painted markings off of it, but I finally got that clean. Now that I got in here, this meter also kind of looks like crap, and it's a little sticky. I might stick a Galaxy meter in here, I don't know. It'll look good with the white face. This one, I also did change the light bulbs to LEDs, so you got a red one and a white one. Red for transmit. Got all the 10 volt and 16 volt capacitors changed. I took it through a little bit of an alignment. That's
what was going to be my main focus of this video, but this escalated very quickly. So let me get this faceplate glued back together while I figure out my next options. I kind of wish they'd still make radios like that where they put the transmit light, you know, behind the meter, so you got a different color meter when you transmit. And Galaxy 959s and stuff still do that. I just think it's kind of cool. Did a little more modifications to this one, but this thing's lacking a mic gain, and I'm thinking about doing an RF power, but I don't want to steal my RF gain. I might put a dual control knob on the back of it for power and mic. Kind of look like an echo control. Still thinking about it, but I haven't taken you all through the alignment steps. I kind of got in a hurry. I had a lot of chores to do yesterday, so I technically did an alignment already, but I can go over the book and show you where all the alignment points are, and also it'll apply to any 858 chassis. So TRC 458, 457, original Washington, Cobra 139 XLR, the original Grant, 138 XLR, Robyn 520D, Robyn, I think it's a 505D, Teaberry 202. Lots of different radios use this chassis. And the only thing that's going to be different in the alignment, some of them have modulation meters, some of them have SWR meters, you know, just different stuff. The Radio Shack ones are more stripped down. But yeah, let me grab a book here in a bit and we'll go through some of that.
Okay, now we're going to go on to the alignment procedure, which you're going to need for this. Get you a little handheld frequency counter off eBay. DC voltmeter with amp function. I'm going to be using this one for this video, but this will work. Looking at the list here, you need a scope, which if you're doing a down and dirty alignment, that won't be necessary, but you do have to have a frequency counter. We'll have to have a DC voltmeter and preferably 50 ohm dummy load and an RF meter. But here's page 1, alignment of the carrier and the oscillator, and I'll show you how that would look. Also, make sure you warm your radio up for about a half an hour before you start. Get everything good and warm. You don't want to align on a cold First step on here, you're going to go to test point 6, right next to L24. I'm doing this with a scope, 10 times probe. Got this scope on the lowest microvolt setting. I would recommend, if you don't have a vacuum tube voltmeter or a scope, just skip this step, because this is your tripler circuit. You want to tune it for peak on here, but if you just have a regular voltmeter, it's not going to be sensitive enough. I would skip this step if you don't know what you're doing. But if you do have an analog scope, you can peak these two until this gets as high as possible, and then on to step 2. Step 2, channel 1 AM, test point 7, which is this guy. L17 is your adjustment. Remember, channel 1, you want about 2 volts plus or minus 0.10. So we're just a hair high. So let me grab ceramic tool, and I'm going to go down on this one here, L17, and I'm just going to adjust it until this goes down to 2 volts even. These can be a little tricky, that's why the plus and minus. That right there looks perfect to me. So that was step 2. Now we're going to be on to step 3. Let me reset the camera. Same as step 1, we're going to go to channel 19 clarifier center position. We're going to look for test point 8 and adjust L16 for max. This is one where I also recommend a scope or a vacuum tube voltmeter. This right here is test point 8. Got the scope grounded. You can see here, this is the can to adjust for the max peak, and I think I've already adjusted it, but let's see here. See, that's down too much. Here's to the right. That's up, 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 up. Peak the can right about there. It looks perfect. So now it's time for a frequency counter on this same test point. Let me reset. Step 4. So same as step 1. AM channel 19, test point 8. I've taken one of these basic frequency counters, set it to high Z, not a 50 ohm balance load. And I've put one of these test leads kits on it here. So we're going to ground it to the chassis. Grab my test lead, take it to this test point right here. Count slower speed, 34,985. See, I've already went through the alignment on this one. See, step 4, adjust to obtain 34.985. So now we're going to go to upper sideband. Make sure your clarifier's centered. 349875, 349875. I've already went through alignment on this, but if any of these are off, let me grab another ceramic tool for AM. Let me go back to AM. So if this was anything other than 34,985, you will adjust right here, CT4, I think it is. No, CT6. This is CT6. You'll adjust that until this is 34,985. And you go to upper sideband, and then it's that one is the CT4, which is this guy here, I believe. That's CT4. Can't really zoom in. I don't have a professional camera set up here. See how it's bumped just a little bit? That is fine. It's fine to have a little variance. So now I'm going to take it to step 5, lower sideband, 34,985, which I've already got that one adjusted. This is your lower sideband one right here, CT5. So 4, 5, 6. Once that's all squared away, then while you're still here, you go to lower sideband again. Well, we're still on lower sideband. Clarifier center position. You're going to transmit on channel 19 and make sure that this number doesn't change. It moves a little bit, that's fine. See, it's a little bit of variance is fine. You got plus or minus 20 hertz is fine. But what you want to do in that case, you want these two to match. There's a little VR adjustment right down here. This doesn't matter in my situation because I've unlocked the clarifier, but you want to transmit and also make sure that that says 34,985 or 9825. So let's move on to the next test lead. It's going to be this guy here. I can get to it on the camera. And that is test point 9. Step 7. So it says go to lower sideband, which we're still in lower sideband. You want to make sure it says 7.7975, which it does. And then go to upper sideband, 7.8025. And the two adjustments for these, if these are off, are right next to these crystals. It's hard to see down here, CT2 and 3. But I've already adjusted all that. So, it's time to move on to the next point of the alignment, the transmitter alignment. The first thing to set on here is bias on your driver and final. This is where you're going to want a voltmeter that can do amps. We're going to break a connection and put a meter in between it and see how many amps we're drawing. Now VR15 and VR16, VR15 would have been here, VR16 would have been here. I've actually moved them to the bottom on this because I put a multi-turn variable resistor on here because these are really tough to get dialed in. And if you have a 300 or 500, I think it's what, 300 I'm gonna have to check on the spec on these, but I think they're 300 ohm. There's not much to them, but the original VR pots that come with these, they're very touchy. It's almost impossible to get your bias just right. But I'm going to show you how to break the circuit and check it. What you want to do for the first one, at test point 4, you want to break this circuit, put your negative lead on this guy, put your positive lead down here on the test point. Make sure you are in upper sideband, and you're going to hold the transmit. What we're going for is 40 milliamps. I haven't tested this. Okay, so we're too high. We're 90 milliamps. So I'm going to have to make an adjustment. Normally you would adjust this pot here, but like I said, in my situation, it was just wildly, it went from like 0 to 100 really quick, and there was no adjustment. So let me flip this over and get that adjusted. Turn potentiometer in there. It's still a little bit high. Let's let it settle here. But it will ease its way down to about 40. You don't want to be over 50. Word of caution, especially if you're using original driver and finals in these, a 2SC 1306 and 1307, it should settle and stay around here. Yeah. So that's just where I want it. Let me move on to the final bias now. Step 2 on this one, you're going to be doing the same thing, but you're going to be breaking the next circuit, which is this one here, negative test lead here, positive test lead there. And then, word of caution, this is a Radio Shack manual, it says adjust this to 15 milliamps. That's what I would recommend. Early Cobra and President manual said 70. If you have the stock 1307 final in there, that's a good way to burn up your final section. I would say 15 to 30 is where I would put it. So I'm going to get this one adjusted and I'll be right back. I upgraded the final in mine to a 2SC 1969. So I have set my balance at about 30. You can go 70 if you really want a lot of heat, but a Radio Shack's 15 is pretty restrictive. I set mine to about 30. But if you have a stock final, I would recommend 15 to 20. There's a lot of service bulletins in the Cobra and President manuals to not do it at 70 like original. So let's move on to the next step. I'm not going to run through this section too much. I'm just going to describe it because I've already done it and I don't feel like making this video 2 hours long. But for transmit, they're recommending you put this on sideband and put a tone through it. You can do AM also, but you want to have 1000 hertz tone, and you want to peak for maximum power into a dummy load. And let me show you which ones you can do. Let me grab a ceramic tool. Let's see. For transmit, L39 is one of them. L37. Come on, focus. There we go. Okay, let's try this again. L39, L37, and then you have over here L30, and I think this one's what, 32? 30, 32, 37, 39. You want to get the maximum transmit out. Don't touch these other cans. That's for receive. You want to keep doing that till you get the maximum transmit out. Once you do, on channel 19, right here, CT7, set that for about 12 watts peak on sideband. And if you notice, VR8 is missing. VR8 is the AM carrier. This is now my AM carrier, and this is now my mic gain, because these Radio Shack ones don't come with a mic gain. So I've removed the mic gain pot. That's the outer one here, and this inner one is my VR8 for AM carrier. But normally, if this VR is here, set it to about 3 to 4 watts on AM transmit. If you want to run an amp, set it at 1 or 2. These things usually only turn down to about 2. So remember, don't get your sideband too much more than 12. You can go 14 or 15. It starts getting distorted after that, putting a lot of strain on your finals. So that is that for that. Of course, to set your modulation, I'm going to recommend you have a scope, because you can't go by really peak. It's supposed to be 4 times your carrier. So if your carrier is 4 watts, you should have 16 watts peak, but these meters are always so far off. That's a hard thing to judge. So let me show you how to set it on a scope, and you can get one of these analog scopes pretty cheap on eBay. So yeah, let me do that. Now would be a good time to get you one of these if you can find one, Syncor CB42. But if not, get you a 1000 hertz tone, play it on YouTube or something, put your mic up to the speaker. And the way that this is hooked up, I have a dummy load. This is connected to the meter to a dummy load, and then I have a tap on my dummy load to go to my scope. So if I key up, still picking up the tone, put this right on here. That's perfect 100% modulation. Take that away, see I'm doing 4 watts. This shows about 12. So that's why I say you can't just go by the meters. But I'll show you what you don't want this to look like. Here's your modulation adjustment. I'm just going to crank it all the way up, I think. Let's see. Nope, that's all the way down. Let's crank it. Counterclockwise on this one is all the way up. I'm just going to go ahead and turn it all the way up and show you what it looks like. That is not good. See the top of this, how it's kind of getting cut off? You're just about getting to box cars. And see how it's pinched down? Now, it looks good on the watt meter, but that's going to sound like utter garbage. So let me get that adjusted back down, and I'll be right back. Now I've got it adjusted just back to where it was. And that's VR7, I believe. That's a perfect modulation envelope right there for AM. So I'm going to leave it at that. For this part of the video, I'm not going to go too much into the receiver alignment, because if you don't have some good test equipment, you can't really flub this with just a voltmeter and a frequency counter. You got to have something that can put out RF. I mean, it's pretty basic. I mean, you can do it without proper equipment if you have a really good ear, but I wouldn't recommend it. Just like all things, proceed with caution. I'm not responsible if you blow something up. If you have no idea what you're doing at all, take it to somebody else. Don't fiddle with this if you don't have to. But I'm on AM. I've got this set to about 25 microvolts, and I'm getting about an S9 on receive. But if you have a signal, if you want to do this down and dirty, you can do it by listening to static, but it's not right, because you might get distortion. But normally you put a signal in here, the lowest possible signal. Let me turn this down a little bit more. I'm just going to down and dirty this here. You turn it down as much as you can. This is where you would go and adjust. Focus. Receive is this guy here, this guy here, this guy here, and here. That's, you peak all of those until you got the clearest, strongest receive you can get. And then on AM, you will peak these. Don't touch this one here. That's for your noise blanker. You need very specialized equipment to make that work right. But I've already done this one, and I've already, you know, if I put in 25 microvolts, should be about an S9. So I've already done that. Same as setting your squelch. In this mode here, you set your squelch to just catch S9 all the way up. So that way, anything over an S9 can still get through. Let's see here. Where's my other pointer? VR1 I have changed. This is your S meter adjustment. You need to do this with equipment. You can't just wing it. You really have to put the proper signal into this to set this, and that the squelch and the meter is usually set at 50 microvolts. So don't flub these, but you know, so that one's your S meter. VR12 was your transmit meter. I skipped over all that because I'm just trying to get you down and dirty to get it working. Your main set of focus, if you're way off frequency or having trouble, is the very first part of this alignment, your POL, and that can be done. You don't necessarily have to touch the tripler circuit or this one. You can do everything else in here with a voltmeter and a frequency counter to get you ready and going. And your transmitter, this guy here, 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 to get you going. Make sure you set your bias. When it comes to stuff like this, receive is not something you want to play with if you don't have the proper test equipment. If you all want a video like that, I can set up a tripod or something, but I'm going to recommend at least something like this Syncor over here and how to do it with that. If you have an actual frequency generator, you have an actual good scope, you have an actual spectrum analyzer, you have all this different stuff, a synad meter, that's great. You probably don't need to be watching this video. You already know what you're doing. But this is just the down and dirty. Your main thing when you get one of these radios and it's way out, it's usually VCO PLL section. Of course, transmit low. You want to play with this section. And you can peak your receive a little bit, but you're not going to be able to fine tune it without proper equipment. So let me get this one all back together and do an overview of all the things I've done and all the things it's doing. Over some upgrades I did real quick. There's a page that's out there. I think his page is gone now, but yeah. You can replace your VR15 and 16 with 300 or 500 ohm multi-turn trimmers. That's what I did to really dial my bias in. So let's go over what else I've done to this. Right here is the mic gain, and your AM power was right here. And I put those on a dual Ranger switch with connectors I can plug and unplug with a dot of glue. So the inside pot on this one's 50K. This original one was 30K. This is 5K. That original one was 10K. But it still works good enough for a mic gain and a transmit power adjust. I did upgrade the final to a 1969. I kept the original driver. It's working good. I'm going to have to clean some of the flux off here before I put it back. So that's what you can... Some of the mods that kind of help get this going. Now I also did upgrade the power supply. This power supply came out of a broken Cobra 139 XLR. The Uniden TF108 transformer, I think it's good for about up to 120 watts, so about 7.5 amps. The original one that was in here, a TF85, they're only good for about 70 watts, so it always keeps this in a constant strain. Of course, I recapped. I've changed every capacitor now. That's why I did the alignment off screen before I got to that part. But all of this has been redone. I got rid of all the corrosive glue, except for one spot I got to touch around these toroids here. I'm going to get to that when I get to it. Of course, I changed the meter. I took a Whiteface Galaxy meter, and this has two lights on it. I've got a red LED and a yellow. Well, that's a white LED and that is a red LED, but I put covers over them to kind of smooth the color to not have a hot spot. So that's what I've done mods-wise so far. And I did replace the AM regulator with a tip 41C, and the power one over here with a tip 41C. And these ones aren't really getting hot, but this is the one for your channel display, and this is the one for sideband, I believe. So AM sideband channel display. Anywho's, let me finish putting this back together and we'll see how it looks. Alright, here's our finished product. Rescued an old mic. Got the cord cleaned up with alcohol. Rescued the dented up case. Beat all the dents out of it. Got the feet back level. Used a little of this tire shine to redo this paint. Did a complete recap. Gave her a variable AM power and mic gain, which doesn't have a mic gain from the factory. So let's see. This looks a little blown out on camera. To your eye, it looks perfect. Midday, so a lot of noise now. Noise bunker. Let's see. Talking on the side
see, down to like 112 dBm. Audio 1 2 3. Audio 1 2 3. Audio about 3 to 16 watts. Audio 1 2 3. Audio 1 2 3. Sounds clean. A&L, PA, which nobody uses. So everything I went through in this video, this applies to the original President Washington, the Cobra 138 and 139 XLR, the original Grant, TRC 449, Robyn 505D, 520D, which I have a lot of these radios here. They are all the same. What's going to be different on the alignment, some of them have mic gain, some of them don't, some of them have modulation meters and SWR meters. But to get the PLL aligned and get you back on the air, everything I covered here is going to work on all of them. And it would be really handy to get you a TRC 449 or like manual for free, especially when it goes through the troubleshooting hints. See, will not turn on, no receive sound, no noise, no transmission. They tell you what to check. Like here, no receive sound. Check for short circuit or broken wire at such and such. They give you a really nice troubleshooting. There's even, if you're having PLL issues, there's even a flow chart. So they can get you through a lot of stuff with just this basic manual. But you can use the original President Washington manual on it also. But what you will notice on the transmitter section, let's see, where is it? Where they go through bias. They say, focus 70 milliamps. See, I set mine for 30. Radio Shack recommends 15. If you get close to 70, it's going to get hot. These radios, that's why they had the service bulletins to get them down to 15. But I put a 1969 final. I could probably run 70. But there it is. There's you a basic, quick and dirty how to get your radio back on the air and what to check for and common problems. So feel free to comment below and with any questions, and I will try to answer them. Now, if you want to learn more about how to use something like the CB42, which is kind of like a dock in the box for one of these radios, leave a comment about that. I'll try to run a video how to do that. It's pretty straightforward. Get you headed down the path of learning how to align stuff. I don't use all my fancy equipment all the time. I do a lot of quick and dirty ones. It's only until I do the fine tune before I sell something that I pull out all the fancy stuff. If something is, yeah, somebody's talking now. Good old channel 6. But if, whenever I'm like really trying to fine tune something, I'm working on ham gear, I'm going to bring out all the big stuff. But these are pretty basic. Other than setting the receiver and the noise blanker and getting all that kind of stuff right, you can do a lot of it with just a hand frequency counter, a hand voltmeter, a cheap analog scope. You know, as long as you got decent soldering skills and can follow troubleshooting procedures. These are pretty straightforward. The 858 is my favorite chassis, if you couldn't tell. I've got a lot of them. So that's all I'm going to say for today. 73s to y'all, and we'll catch you in the next one. Toodaloo.